Hello, Abraxas here, and I'm going to be playing some Universe Sandbox 2. Okay, so I have a suggestion from John Gray. This is actually an older suggestion, and he asks, try to terraform Earth while orbiting around a red dwarf star, including Mars and Venus also. Okay. So, which red dwarf should we use? We have Proxima Centauri. We could use Wolf 359. That's like the, I think smallest star in the game. I could be wrong. And I don't know, is there any actual other red dwarfs in this, or... Yeah, here's a couple. I don't know, I don't really want to use Alpha Centauri, I feel like, or not Alpha Centauri, Proxima Centauri, because I feel like I use that one too much. We could use Wolf 359. Now, let's see how far the actual habitable region is on this, because we're going to need a little bit of space. Ooh, I don't feel like that's really all that far. It is a really small star. Yeah, I don't know. I think the orbits might interfere with each other in this case. Okay. Yeah, let's try something a little bit bigger. Something that's not Alpha Centauri, though. Castor, I think Gemini, I think that might be, CA, is 650. That's 189. That's an orange giant. And none of these are that much bigger. I think this is like the biggest red dwarf in the game. Trappist. How big is Trappist? I think that's really small as well. Let's see, let's go ahead and clear this. Oh, that looks like it's actually quite a bit bigger. Now we're just zoomed in a lot. No, that's actually really small. Oh wow, that is tiny. But look at that, you can see solar flares just ejecting on that thing like crazy. Because even though it's a small star, it's a very, very active one. And just try orbiting everything around this. We'll do this in such a way that it's kind of similar to the solar system. Let's go ahead and just orbit Mercury roughly right here. Hopefully it doesn't just burn up in a comet tail. No, it looks like it's actually handling it pretty well. And the temperature is actually quite similar. Pretty cool. Okay, so I guess we'll put Venus also a little bit closer. Sorry, I did bump my microphone there. Okay, Venus would go right about here, I would think. Kind of in that green-red area, the habitable region. And it's sitting at a temperature of 340 degrees. That's actually pretty close. I think Venus is a little bit warmer than that. I could be incorrect. I guess we'll put Earth right about here, where it is sitting at 15 degrees Celsius. That's actually pretty much spot on. I think in the game it actually is 10, but I do believe Earth is at 15. I could be completely wrong about that, but that's pretty close. That's actually very habitable. Now, the thing about everything that's orbiting around Trappist-1 is we do believe, or we're predicting, that it is actually tidally locked. So let's actually tidally lock all these planets. Go ahead and just tidally lock it right here. Oh, yeah, that actually changes axial tilt too. And there goes the ice caps. All the ice caps are probably going to be on the backside now. Let's go ahead and view this in studio lighting. It's not quite frozen over here. Let's go to climate and see if... Okay, let's toggle this on and off. Well, nonetheless, it's orbiting with the star now. Or rotating with the star. We'll just tidally lock the rest of these while we're at it too. So let's go ahead and tidally lock all these planets. Pretty cool. Let's go ahead and add in Mars, which would be roughly right here on the scale of our solar system. And let's also tidally lock it. Notice that removes like its axial tilt too when it tidally locks it. I wonder if that's actually a thing. Interesting. And for the heck of it, we'll just add in the other planets. Let's go ahead and throw Jupiter right over here. And Saturn, let's throw it like right out here. Uranus will go over here. And Neptune will go like way out here. There we go. So there's our entire solar system orbiting around Trappist-1. I ain't gonna bother to totally lock those. So there you go. There's Earth, still habitable, orbiting around Trappist-1. And it might be freezing over on one side. That appears to be what's going on. Let's go and speed up time and watch this kind of just snowball over on half its hemisphere. Oh yeah, it does that one flickering thing, that's right. Unless I speed up time enough. I think there's a way I could actually make it not show the rotation. There we go. Now we just want to speed up time more. And it turned into a snowball. Wonder why that is. Let's go ahead and change the view to orbits. It's still in the proper orbit. I just don't know why it really went snowball. Oh, the surface temperature dropped down to 39. That's probably because I sped up the simulation too much. That does cause problems typically. Yeah, I think I bugged it. Go ahead and zero out the temperature and just see what happens. Oh, that's a bit better. It's freezing over at the United States. Interesting, we just have large polar caps. Well, the temperature's still dropping. But it doesn't want to actually freeze on one hemisphere, even though it's tidally locked, supposedly. Or is it? No, I don't think it's actually tidally locked with the star. Let's go ahead and just change the lighting back to normal. No, that is not tidally locked. It's not actually rotating with the star. Oh, no, wait, that's because I turned off rotation. Derp. The rotation doesn't actually physically stop it, so the climate should not really be affected. Okay, yeah, that is still tidally locked, but I don't really know why it's still freezing at the poles, and why it's not actually just freezing on one hemisphere. It's because the overall surface temperature is actually dropping. Interesting. I would have thought it would actually be able to keep it warmer than that at this distance. I guess I'll have to move it a little bit closer. He did say to keep Earth habitable. Okay, let's go ahead and change the semi-major axis. Let's go to astronomical units. Halt the simulation. You know, really, I could just move it a bit closer. Let's just drop it. There we go. That should hopefully warm it up a little bit. It's actually kind of interesting that it still freezes over even at this distance. I would consider it really close to the star. Interesting. Starting to get into the warmer region of the habitable zone. Let's go ahead and make it a little bit closer. Hopefully not clipping towards Venus, which probably has a significant pull on Earth now. I'm not gonna lie. And still just really cold. How close does Earth actually have to be habitable around Trappist? Okay, let's go ahead and halt the simulation, that way we don't have any unnecessary collisions. And let's go ahead and actually just remove Venus from the equation, which is still at its temperature, by the way. The greenhouse gases are pretty sufficient for keeping it warm. And let's go ahead and drop the semi-major axis of Earth even more. Let's put it right about where Venus was and hit play, and see if it heats up. Okay, the temperature looks like it's stable now. Let's go ahead and drop it to 0 degrees. Okay, so I've zeroed out the temperature. I think the game just lagged as it was rotating songs there. And the temperature is pretty much stable at around -2 degrees Celsius. I sped up the simulation, which causes a little bit of inaccuracy in the temperature, but okay, let's go ahead and move it just a hair closer. And maybe that might be enough to actually warm it up. Temperature graph. Well, it's going up. Not quickly, but it is. Okay, so now we're actually getting to a proper temperature. which is kind of interesting because we are very, very close to this star. Let's go ahead and break the camera view. Wow, that is interesting. So the temperature is going up. We're finally kind of in the habitable region for Earth at its current atmosphere and albedo, so yeah, that's kind of interesting. Earth actually has to be really close to the star, which might not be such a good thing, because as you can see, this star has a lot of solar radiation, a lot of just solar flares happening, so we definitely would not be the technology-rich planet that we are right now. If we even tried to get a power grid up, this star would probably be kicking it down immediately, which would not be good. And it would probably pick off our atmosphere rather quickly, even though it's not as big of a star as the Sun. It's a much more active star, so even though we do have our magnetosphere, it might not actually protect us from that much solar radiation. Can you imagine the lighting on this planet? Look at how much dimmer it is than the Sun. It's like much more orange, I guess. Interesting. Well, there you go. There's the solar system orbiting around Trappist-1. And there is Earth in the kind of habitable region, I guess. I guess what I could do is I could probably adjust for this and add Mercury like that close. Try to squeeze Venus in like right here. That is probably not stable if I were to guess. Right, the camera view. I think over time, Venus and Earth are probably going to pull towards each other. But there you go, the solar system orbiting around Trappist-1. Anyways, if you guys liked the video, please leave it a like, and if you want to see more videos like this, please do subscribe, it really does help. And I will see you guys in the next one.